Hello everybody. Today I'm going to show you how to do a projectile motion problem. We're going to start by identifying what we need to find. So a football is thrown from the ground with an initial velocity of 15 meters a second at an angle of 35 degrees. So just to start out, let's just draw this out. And right here we have y going up and down, and here is x. Excuse my awful drawing skills. And right here we will draw where the max height will be, and just label that. And over here is where we were trying to find how far the football went. And we can write out max d of x and max d of y. So based on the information we're given, we can take this triangle here and draw it out like this. And we know that this is the hypotenuse, this is the adjacent side, and this is the opposite side. And we can write in that we have 35 degrees on this angle from where it's thrown, and an initial velocity of 15 meters, so that goes here. And we can determine that the initial velocity of the y is over here, and the initial velocity of the x is over here. Now, to calculate out what this is, it is sine of 35 degrees equals the Vy over the hypotenuse, so 15. And then you can just do 15 sine 35, throw a little degrees in there, equals Viy. And that is going to come out to about 8.6. And down here, we're going to do, to find the initial velocity of x, cosine of 35 equals the initial velocity of x over, once again, the 15. And then you multiply it just like before. So 15 times the cosine of 35 equals initial velocity of x, and we're going to find that the initial velocity of x equals about 12.3 meters. So then we're going to draw it out in two separate graphs or charts. So over here is the x max. Over here is, this is the y max, and over here is the x max. So we're going to plug in what we know. So x, y, and write in all of this fun stuff, which takes a moment. And then over here. And so what we've already determined is that the Vi is 12.3 over here and 8.6 right here. And the same goes for over here, 12.3, 8.6. Now what we know is acceleration is for x, it's 0, and it's negative 9.8 because of the free fall over here, and that is meters per second squared for both. These are both meters per second over here, and the same goes for over here, where it is 0 meters per second squared and negative 9.8 meters per second squared. One thing we also can note is that the distance is going to be 0 for y, for finding the max of y, because up here there's going to be, you'll notice right here is where 0 is, and that's what we're trying to find, is that there will be no forward movement from there because it's the absolute top. So how we're going to use these now is by calculating out, by using one of our formulas, we're going to try to find t, because we have delta d, acceleration and initial velocity. So to do that, we're going to use the delta d equals VIT plus 1/2 AT squared. And so the way we're going to do this is that delta D equals, plug in that we know that delta z is 0. And why we're doing this, let me just explain really quick, is that the t's over here equal each other, and we're trying to find the time for over here in order to plug it back into the equation so that we can find the delta d, which will help us find how far the football travels. Realizing now that this is the second one we were going to find, but it doesn't matter. You can do them in either order, and we'll go back over here to find the max height afterwards. And so we start out with 0 equals, we plug in our initial velocity, so that's 8.6. Time we don't know yet, so we're going to put t. I'll just put some parentheses around there. Plus 1/2 acceleration, so that's negative 9.8. And t squared, just like up here. So then we're going to, we know we can subtract, so 1/2 of negative 9.8 is 4.9. So we can subtract that and put it over here in a new equation. So negative 4.9 t squared equals 8.6 t. And then we can divide by t, and cross out these t's. So then there's only one t left over here. So then you have negative 4.9 t equals 8.6. And then you can subtract negative 4.9, subtract negative 4.9, and you can find that t equals 1.76 seconds. So then we can plug this information back up here and find that 1.76 and move it over here because it's the same thing, 1.76. And now, since we have time, acceleration, and initial velocity, we can go back and use that information. 1 second while I find the right equation. So we're going to use the same equation, actually. So over here I'll do it. Delta D equals VIT plus 1/2 AT squared. But since we're using the x side now, we know that A is 0, so this basically, since this is 0, it totally cancels out this entire part. So we're going to have a very basic thing, which equals the delta D equals VIT. So then we can plug in the information we know. So delta D equals, we know that 12.3 is the initial velocity, and for time, 1.7 seconds. So then we multiply that out, and we find that delta D equals about 21.65 meters. So we now know, for up here, our question, that how far the ball travels. It travels 21.65 meters. So we're halfway done now. For the find the max height, we're going to go over here, and what we're going to do is use the same, we're not going to use the same equation, but we're going to use one of the equations that we've learned in a previous lesson to find, so using VF squared equals VI squared plus 2A delta D. And so for VF, we know that the final velocity for up here, it's going, the y is going to equal 0 because, as you can see, it returns back to where it is. So that's important to note, because then when we do this, we have VF, VI, acceleration, and what we're going to find is right here, which is delta D. So we plug in all this, and we find that, so 0 squared is obviously 0. VI squared is going to be 8.6 squared, which, whenever you do it out, it's going to actually equal 73.96. I'm just going to jot this down over on the side there. Then we add plus 2, negative 9.8 is our acceleration. That's not an 8, there it is. And then delta D, which is what we're going to find. So then we know that, so this is 0, so that's out. We're going to do we're going to subtract the 8.6 squared, which is 73.96. So then we have 73.96, so that's over here, equals 2 times negative 9.8 is negative 19.6, and we're going to have d delta d right here, which is still what we're trying to find. So then subtract negative 19.6 from 73.96, so you get negative 19, not what you get, but what you're dividing by. And then you'll find that delta D equals 3.78, about 3.78. So, meters. And so, we now know that this is actually what we're trying to find. This is actually the maximum height. So we can put that in here, 3.78 meters. Circle it just to make it look nice. And we're done. And that is how you do this projectile motion problem. Thank you for joining me.